This is a Q&A webinar following up on Lithium 101 from last week. You should be able to see my screen now. I'm the presenter, and we're going to have Christine Fedoroff doing the Q&A. So you can write into those windows on the webinar. You can get answers while I'm presenting. We're going to do 40 minutes of Q&A where I'm just presenting and going over slides, and they'll 20 minutes live. If you have a question during the live session, raise your hand. The topics today, we're going to jump through some categories to make it a little bit easier to digest the info, and here they are. And we've got a title slide, so you'll know what section it is as we progress. So I think without further ado, we're going to go ahead and dive in here. The first question. We're going to start with some charging questions. So the very first question we have is, can I use my lead acid existing charger, wet or AGM, to charge Reliance lithium iron phosphate batteries? What are the implications? So the question as it came in was wet or AGM, and I just want to say include gel battery chargers with that as well. And we covered this in the 101, and our lithium battery is very battery charger friendly. It is likely that your charger is going to work perfectly fine with our lithium iron phosphate batteries and charge them to 100%, and you won't, without hiccups. Now, if you really want to know some more detail, it's listed here. A lot of chargers nowadays have a lithium charge profile, so and it's usually geared for lithium iron phosphate. So if you have that, great. You click that and you'll get an optimal charge. Sometimes you don't even know. Check your manual. Most of our customers have an AGM or gel charge profile if they're not already using it. And quite often that's also almost ideal for charging our batteries. It's a seamless charge, and you get the battery charged and everything works well. The voltages are exact and everything. When it comes to flooded battery charge profiles, we discourage that. Often they're also compatible, but you really have to consult your manual and kind of know the voltages. The risk there is that you might overcharge the battery a little bit, and the BMS might disconnect and you'll get an error message at the end of charge. But the battery wasn't damaged or harmed, and the battery's fully charged. So you just disconnect the charger and use the battery. No harm done. Second question, what is the optimal charge currents for lithium iron phosphate? And can you provide an online reference for this? A couple of answers here. Yes. Our reference for charging instructions is online in our document library. So just go to our website. You follow that little screen there to the resource sections, and you'll find a place where you can get our charge instructions. As you see, it's listed here. Don't want to go into too much detail, let you read it, but a couple things we'll be touching on repeatedly throughout this is we recommend a 0.5C charge, although you can charge up to 1C. And the voltage range you're looking for to charge the battery to is 14.4 to 14.6 on a 12-volt basis. And you just increase that incrementally, or the proper multiplier for larger voltage systems. That would be a simple single stage. If you go to 2-stage, then you do the same thing, and you hold that voltage, called absorption voltage, and you let the current taper to 5% of your total amp hours, what we call 0.05C. Okay, again, we'll be touching on that throughout the 40-minute slide section here, or actually the whole presentation. Question, Reliance specs say 14 to 14.6 bulk charging, 13.8 float. How much deviation from these figures is acceptable in charging? So if you recall back in the webinar 101, we really, one of the strengths of lithium batteries is they can function in a partial state of charge, and they also have protection against overcharging. We have an internal BMS. So for starters, there's a large deviation you can have. The risk, ideally, you charge the 14 to 14.6 volt range, and you're 100% charged. And if you float, you make sure you're balanced and everything, that's optimal. But if you don't do that, if you undercharge, disconnect your charger doesn't charge to that, or it charges to more, there's no harm. The two conditions you've run into, of course, if you undercharge, you won't have your full capacity. You might have 70%, 80, 90% of the amp hours, something to that extent. It doesn't harm the battery short-term or long-term. If you overcharge, you do risk the BMS sensing the higher voltage and then disconnecting for a period until you either the charger stops charging or you disconnect it. Again, no harm done to the battery in those conditions. Charge rates. We've recommended 0.5 C up to 1 C. Those are considered medium and fast charging. But this question comes in, is it detrimental to charge slower? Way down at 0.05 C or 0.1 C. In that common scenario in off-grid systems. Absolutely no harm in doing this. You can charge, again, one of the big benefits about lithium, you can charge slow, medium, or fast, or really slow. The battery will get charged. There won't be a harm, just will take longer. What type of solar charge controller do I need to charge my batteries with my solar panels? Well, there's a couple embedded or hidden questions here. Primarily, people are asking, there are two types of charge controllers, PWM or MPPT. And both are compatible with our batteries. MPPT is a little bit more efficient. You get more of a charge. So the industry, the charge controller side of the industry will promote that. We're indiscriminate. You can pick either one and our battery is going to get charged. To the previous questions, you're looking for something with either charge programmability. You can put in the voltages for lithium iron phosphate, or you have a charge profile for it, or at the very least, you have an AGM charge profile on the charge controller, which most do. Okay, I see we've got a couple questions coming in on the Q&A chat box. Just wanted to point that out for those of you who might be interested. Bear with us. Okay. Okay, next question. So here's I wanted to share this question that came in. It was something that's really rather specific, and I think a lot of people have, is they've got a charging device or controller, be a charger, and they know the specifications, and they want to reach out to us and find out if it's acceptable. So here's an example right here where that happened. The person spec'd out a device on their RV. It's called a converter, which charges batteries. They gave me the model number, and they actually pulled the values from the manual listing the absorption, the bulk values, and the float, and asking if it's okay. And in this case, you can see in the bulk mode, it lists an ideal voltage of 14.4. It's right in the sweet spot. Now it'll only do it for 4 hours, so he's a little bit limited there. You'd have to get to that voltage in 4 hours. So otherwise, he's going to float at 13.6. So there might be a little undercharging if the charge takes a while. But knowing these devices, and this is better if you kind of come to us on a tech support line or an email. This question, we give you a little more attention than we can here today. But this, at first glance, this looks like a really compatible charge profile. But without knowing the batteries at a specific charge rate, can't answer for sure. But hopefully that makes you, a lot of you out there feel comfortable with your chargers. What about a straight DC input, no profile? So this is a really tech-savvy person emailing in. The skinny here is there are devices, power supplies with just output a constant voltage or constant current, and they're wanting to know if our batteries can accept it and get charged. Yes, it will accept that current or that voltage and get charged. The gotcha is we do have an internal BMS. It's not going to regulate that charge. So more than likely, unless you're sitting there babysitting it, the power supply will overcharge and the BMS will step in and disconnect when it's all full. There are lithium battery designs out there that have an external BMS that do all the charge regulating with the voltage and the current, and they actually want a power supply. We are not that design. We have an internal BMS. Those other styles usually require a high amount of technical knowledge to connect all the cells and the wires and the sensors and the BMS. So we've opted to make our batteries simple, more simplistic and user-friendly. But you can do this. A lot of questions came in on about alternators. So we're going to provide the knowledge we have there as best we can, because there's a lot of variability on alternators in the marketplace. So does Reliant Batteries BMS throttle the charging current not to overload the stock alternator? Our BMS is internal and it's there to protect the battery cells in itself. It does not regulate the charge coming in. So no. If the alternator wants to put out too high a voltage or current, the BMS is simply going to step in and disconnect if it sees something that's out of the acceptable range. But typically alternators are trying to put out a 14.4 volt range, so they're compatible in that sense usually. However, alternator current and voltage do fluctuate a lot depending on their design, whether the motor's in high RPMs, etc. If the batteries are still being charged at 14.4 once fully charged from an alternator, will this damage or reduce the life of the batteries? So this would really be called a constant voltage or a float at 14.4 if you were continuing to rev an engine, an alternator kept putting that out. If you were to continuously do that to our batteries, eventually the voltage would drift higher and the BMS would come in and disconnect. But since alternate in that long term would reduce the battery life a small percentage, 10, 20%. However, with the nature of alternators and engines only operating a part of the time, it's not really a factor and you probably won't reach that disconnect. Nor will you reduce the life of the battery significantly. So no, it's not harmful. For alternator charging, doesn't the alternator output a load only for load demand? Doesn't only satisfy the load demands is what this question's asking. And if the battery's fully charged, won't the alternator simply sit there and not force electricity into the battery? Yes, once the battery rises, gets fully charged, it'll match that 14.4 volts that the alternator is putting out, and there'll be very little current, if any, flowing back and forth between the battery and the alternator. Now, the gotcha is alternators have temperature compensation, and that voltage moves around based on if it does indeed have a temperature sensor or not, and if that's placed at the starter battery or the house battery. So again, just harkening back to the webinar from last week, we have plenty of users connecting our batteries to alternators and reporting great results. We get very few, if any, complaints back in or issues, but the safest route, or really the most compatible route, is to install a DC to DC charger between the alternator and the battery. And we gave some options for that back on the webinar from last week. Here, another question. We're getting pretty specific. Will a 160 amp alternator overcharge a bank of 4 100 amp hour lithium batteries? How do you manage this on a boat? Can you manage this on a boat or a car or any other vehicle if there was an issue by installing it, what I just said, a charger in line between the alternator and batteries? In this specific case, 160 amps, would it be compatible with that bank of batteries? Let me just consider the example of one battery to paint the picture. A single RB100 has a max charge current of 1C. That means 1C is what it's rated at, 100 amp hours. So 100 amps is what it can do. So this alternator would overcharge a single battery. Now that you have 4, that current tends to get spread out over those 4 somewhat evenly. There is some imbalance in the current share, but roughly each battery is going to see about 40 to 50 amps of that 160. So it's going to be okay. That's well beneath the 100 amp max of each single battery. So in this case, it's going to be okay. Likely to be okay. So some questions came in on our products. We have quite a few different versions of the RB100, which is a popular size. You'll see here a picture of the RB100-HP, and we have the base model RB100. So the question is, the HP series, will it work well in a boat for both starting and cycling? Yes, that's what this battery was designed for. HP stands for high peak, and our standard RB100 has a peak current of 200 amps. And there's a lot of marine users that have a small outboard or outboard motor. They want to crank that motor in the morning and later in the day. And they might see 300 or 400 amp peak to get that motor started. So this has a peak rating all the way up at 800 amps for 3 seconds, which is more than enough to get the job done on many marine motors as well as larger motors. And it can cycle as well. So it's really designed to be a true dual purpose battery in the marine market. What is the difference between Reliance HP, LT, and X series batteries? Great question. We went a little over the HP just now. The LT series stands for low temperature, and we touched on it last webinar, but it allows our batteries to be used in the cold, and all our batteries can be used in discharge in the cold. It allows the battery to be charged in the cold as well. And we have a lot of questions on cold temperature, so we'll touch a little bit more on LT there, but it gives you more versatility and range cycling in the cold. And the X series, it's not only those batteries have a higher peak and a higher continuous rating. Whereas the HP, we have a higher peak current rating. The X series, you get even more versatility on the amount of current you can pull. Both continuous and peak. Let's get into some discharge questions. Slide. Okay. I heard you cannot really discharge a lithium battery 100%. If you do, the batteries will not restart again. Is that true? Okay, so there's a few points we want to touch on here. This is a great question. Let me just step through these in the best order possible. So, can you discharge a lithium battery to 100%, and will it harm it? Yes, you can discharge a lithium battery to 100%. Of course, if you do that, the battery is depleted, the capacity is gone, and the BMS is going to do its function and disconnect when you're at 100%. That alone in itself does not harm the battery. What does happen is when as long as you're connected to the equipment and there's a load present, and that the circuit stays connected physically, the BMS will remain disconnected, and you won't have battery power. You actually have to go in and physically disconnect the battery, and it will recover or reconnect, or a couple of terms people use. In this case, the gentleman said restart, and that potentially is what he means. Will the battery reconnect? And only do so with a physical disconnect and reconnect. Right now, we're working on future products that might not have that characteristic. If the battery reconnects, you'll want to get a charge into it within a few weeks, preferably right away. But if you wait a few weeks, the battery will eventually self-discharge again, and then it won't self-recover. You'll need to actually bridge it to another charged battery to get it to wake up or reconnect it. It's a practice we don't like to recommend. So we strongly encourage people, if they do discharge 100%, to get the battery on charge right away. And then, like any battery, you don't want to leave it fully discharged for weeks and weeks and months. If you were to do that, you could potentially damage the battery. So it's kind of 3 grades of answers. Hopefully that gives you a good picture of the implications of discharging a battery to 100%. A lot of equipment out there has settings for a low battery voltage cutout, LBCO, LVCO, LVD. So it's a good practice just to set your parameters. If you need help with those, contact our tech support. But to have your battery disconnect at 90% or 95% discharged, so you just avoid the nuisance of a BMS disconnect. How many CCAs does the RB100 have? Well, we don't rate lithium batteries with CCAs. That's specifically a 30-second discharge in freezing temperatures. It just doesn't correlate to lithium. For starters, we have a BMS in there with circuitry, so we don't want to have high currents being pulled at 30 seconds. So we rated at the peak rating. And the peak rating of our standard RB100 is 200 amps for 5 to 10 seconds. If you need some true starting capability beyond that, or cranking capability, then we have the RB100 HP, which I already detailed the specs on that, up at 800 amps for 3 seconds. Okay, questions on our BMS. So I've already mentioned we have the internal BMS. Question coming in, do our BMSs talk to each other when you parallel the batteries? Connect them in parallel, or even series is a good question. Are they help managing the whole bank together? Answer is no. Currently, our BMSs manage each battery individually and keep that battery balanced internally and protected. And there's no interference between the batteries and the BMSs either. Temperature-related questions, especially with the cold. So here's our table, pulling this from our last webinar. So the temperature range, depending on what you're discussing, varies. For starters, the discharge range of our lithium iron phosphate batteries is considerable, from -4 degrees Fahrenheit to 140 F. And substantial capacity to all those temperatures. I didn't import the graph from the last webinar, but you can remember this far exceeds the existing battery technologies and what they can do at those in that temperature range. Lead acid batteries particularly are really sluggish in the cold. If you're lucky to get any decent capacity out of them, and lithium, we're north of 50 or 70% capacity in most cases. When you're charging batteries, you can charge lithium, you charge them slow, medium, or fast in that wide moderate temperature range from freezing to 113 degrees Fahrenheit. No concerns. When you get into the cold, you want to only charge our batteries slow. Got a chart a little bit later on where we'll actually look at what that means. But for those of you who don't have cold temperature applications, you don't have to worry about that. Those of you that do, the question is, are you charging when the battery's cold? If it's just stored, it's a different story, or if it's being discharged. If we're going to charge it, then we'll pay a little more close attention when we get there. But slow charge typically means 10% or slower. So if you have 100 amp hours, 10% of that is 10 amps. But again, more detail to come. Storage. Right now we're recommending 23. This is really more of a long-term storage, but 23 degrees to 95 Fahrenheit is what we're recommending. I think there's a question that pertains to that, so we'll get there in a second. How well do lithium batteries function below freezing, and how well can they charge below freezing temperatures? For starters, I've already said we're much better than lead acid. Let me just share that we've got batteries working in several batteries in Canada, fleets of batteries in Sweden, batteries in Denmark. So all around the world in cold climate zones, and they're operating exceptionally well. We get nothing but rave reviews back at how remarkable the lithium chemistry is working for them. How well can they charge below freezing temperatures? Again, if you get below freezing, you got to slow the charge rate down. The beauty of this is most applications already have chargers geared for lead acid. And if you recall, lead acid batteries need to be charged slowly. So again, there's a seamless, compatible match between the charger charging slowly already. So there's no real concern, and the chargers that exist for equipment can charge our batteries in the cold as well. So sort of a natural existing solution. Can the BMS protect the battery from receiving a charge below the acceptable temperature for charging? No. Our BMS, our standard BMS in our products, our analog BMS, which is in most of our plastic case product, does not have protection for cold temperature charging. You've got to do that on your own manually. Monitor that. We do have a few products with a digital BMS and comes in the steel case and 48 volts usually, and you can email us if that's the product line you're working with if you need to get this question answered further. But for the most cases, no. 32, okay. Other than the RB100 LT, does the BMS adjust the charge rate when at 0 degrees F? So again, the BMS is in all our product. Well, they don't adjust the charge rate, first of all, when it's cold. And there's no protection there, except on a few 48 volt models, steel case. With the RB100 LT specifically, it also does not adjust the charge rate. Its functionalities, if we're below freezing, that battery's going to use the charge current to heat itself up. And then when it gets above 0 degrees F, specifically 5 degrees F, it'll allow the charge to proceed. I'm going to jump ahead here. Oh, nope, sorry. I'm not going to jump ahead. So cold temperature charging concern again. Customer in the UK where they does get to -10 occasionally. And he's got a small solar array, 300 watts. He says there's limited sun. Will it be okay? Well, this sort of condition exists. It's widespread. It's almost an organic solution again, where you have a big or a small temperature array, but you've got limited sun. So the output of your solar array is pretty low, and you're going to be in a slow charge condition already. So is there really a concern to really monitor that charge? It's really system specific, so I can't give a blanket approval here, but quite often there's really no need for concern. Once you crunch the numbers, you realize you're, in cold climates and when the weather's cold, there really isn't a threat of too much sun delivering too high a charge to those batteries. Is it true you cannot store a battery below 23 degrees F? That mean the battery is not suitable for temperatures below 23 F? So that's our recommended storage range between 23 F and 95 F. That's going to preserve the battery and provide the longest life. The implications of long-term storage outside that temperatures is really, it's something you want to try to avoid if you can. It's unknown what really happens long-term or how much degradation there is in the battery. So that's our recommended setting. And that's similar to all lead acid batteries too. You can't store them in freezing temperatures. They actually have liquid electrolyte and they'll freeze and damage the battery. So it's a good idea to continue that practice even with lithium batteries. But we've actually extended the temperature range down to 23 degrees Fahrenheit. And again, we're using our batteries in Canada, Sweden, cold climates. They're being used. Battery generates a little bit of heat on its own, and it's just fine operating in those climates. You said the batteries can be charged slowly below 0 degrees. What does slow mean in amps? Let's take a look. So we've expanded that same chart that we began this section with. Just want to focus on the charge section. Line 2, the charge is for the moderate temperature, so we're going to skip over that. We've touched on it before. When you get into lines 3 and 4, I'm going to switch to Celsius on you, but from freezing to -10°C is one segment, and then from -10°C down to -20°C is another. In battery terms, you want to charge at 0.1°C for the first and 0.05°C for the second. Those coefficients, 0.1 and 0.05, really translate to what you might consider 10% of C or 0.5% of C. What is C? C is the amp hour rating of your pack or your one battery, if that's what you have. So if you have a 100 amp battery, which is column 3 here, that's the kind of example we chose. 0.1 C winds up being 10% of 100 amp hours, so it's 10 amps. So you can charge within that 0 to minus 10 C temperature range. Likewise, gets colder, you're going to be charging at 5%, which would be 5 amps for every 100 amp hours. If you have a 200 amp hour system, then you just double those two numbers. I think that's pretty straightforward. If there's more to ask about that, we can deal with in the live QA section. Can you provide details on charging and cold temperatures, the internal heating pad, temperature thresholds, and draws off charge sources for the LT series? So to revisit, the LT series does have an internal heating element in there that's 110 watts. It's sized properly to handle heating the battery up in the freezing to -4 -4 Fahrenheit temperature zone and heat it up to +5 Fahrenheit. And then the battery will start charging itself. So that's how it functions. I'm not sure what other parts of this question we can address, but those are the basics of operation. And again, this is a line of batteries. I think we have a couple more models we might have added to this. Same with the HP series. So you're not just limited to the RB100 if you have to deal with low temperatures. So questions on some operation. Okay. And we're just a little over halfway through the presentation. So I might go a little bit swifter here because we do want to open this up to the live Q&A. So just bear with me as I might get, my answers might get a little speedy here. I was installing an RB100 HP for my starting battery on my boat and an RB100 and 2 of them in series for a 4-volt trolling motor system. If you read the rest of that question segment, basically the question that comes out of there is, do I leave my charger plugged in or do I unplug it? And you really have the freedom to do either. There really isn't any harm in leaving the charger connected. Usually chargers have timeouts anyway at 24 hours or something where they stop charging the battery. If you happens to be float charging, it's not a tremendous setback to float charge the battery for a long period of time. You might lose 10 to 20% of the life. So there's a small preference, we would say unplug it, but it's not really, most batteries shut themselves off. There's no harm to unplugging it either. The battery's going to get charged, it gets charged, and it's done. If I connect my batteries in parallel, does that increase continuous peak charging currents available to me? So there's a question not getting asked here, and I want to answer that one first. When you connect batteries in parallel, so you have 2 100 amp hour batteries, your capacity doubles. It's great. You have double the runtime. But the question here is specific. Can I also double my continuous peak and charging currents available to me? So can I now charge at 200 amps? And the answer here is no. The internal resistance of batteries with all batteries, but specifically lithium, I should say with lithium, it's no different. The current's not shared evenly, and we want to caution people against doing that because we don't want you to harm the BMS. So we suggest that you derate, you double it and then multiply by 75% to get your max values for continuous peak and charging. In the example of charging a pair of RB100s, if it doubled, it would double the 200 amp charging potentially, multiply that by 75%, and you get 150 amps is what we would recommend as the maximum right now. And again, we're working on new and that's really the challenge of all the batteries out there in the marketplace right now that are lithium. We're working on technology to change that. So, just stay plugged into us and our announcements, and we'll have products coming out in the future that can deal with that limitation much better. How can I determine the state of charge with my lithium iron phosphate batteries? Well, that's an easy one. You want to buy the Relion battery fuel gauge. Measures amps instead of voltages on a battery, so it's much more accurate. And this is for both discharge and charge. You'll be able to tell what the state of charge of your battery is much more accurately. The reason for that is, back with lead acid, gauges that were semi-reliable at best that were geared off the voltage of the battery, the degradation. And here's a graph of the battery voltages. You see how stable it is on the lithium, these 4 lines. It's really hard to distinguish what the state of the charge is on voltage anymore. Here's a simulated line of a lead acid battery where so much more of a gradient where you can try to distinguish the state of charge. But even with lead acid batteries, that was really a crude way to go about it. And that line really changed with temperature and life of the battery. So we've really improved the industry by switching everybody over to, requiring everybody to switch over to fuel gauges that measured amps instead of volts. Okay, it brings us to the miscellaneous question sessions portion. We're at the 40 minutes, so I'm gonna open it up to live questions here in a second. If I didn't mention already, use your digital hand raising feature for that. I'm gonna look for 1 or 2 questions in this miscellaneous section just to see make sure we get. Are there any problems with altitudes above our batteries at altitude? No, the altitude doesn't affect our batteries, but as you go up in altitude, you get colder climates. So we've discussed that. And there could be implications there. What certifications are required to ship lithium iron phosphate batteries in the USA? Covered in the webinar. You got to have UN 38.3 certification to ship batteries throughout North America. And if you don't have it, those batteries are illegal and they should not be on the highway or in any shipping vessel. What would you set Pucherts to in an amp meter? Well, our batteries are super efficient. If you didn't know, Puchert coefficient is to accommodate and adjust for the inefficiencies in lead acid batteries. I showed this graph in the prior webinar. You can see that the green line, an amp hour is an amp hour is an amp hour with lithium. You get 100 amp hours out of a 100 amp hour battery all day long, no matter what current you're pulling. Once you start pulling slow, medium, or fast currents out of a lead acid, it becomes inefficient. You don't have 100 amp hours. So you got to have a way to gauge how much you're being taxed. So that's the Puchert's coefficient. So we recommend a Puchert coefficient of 1, which represents 0 inefficiency, or, battery's 100% efficient. There is documentation that suggests you might put in 1.02 to 1.05 for a lithium battery. And that's really to accommodate for really high rate loads when you get up around 3 or 4 C, which most people don't encounter. So you really be safe to use a Puchert number between 1 and 1.05. We'll let you, your discretion, you can pick. Okay, we're 42 minutes in. I think I would like to open it up. Last question, what is the disposal process for a lithium iron phosphate battery? Right now, the best thing to do is just call a battery recycler or a recycler period of metals or lithium battery manufacturer, and they can tell you. There is a website we'll direct you to called Battery Recyclers of America. You have a 1-800 number. They'll help you dispose of the battery. Usually going to require a pickup or drop off at a specified location. Okay, I'm moving over to the live Q&A now. Bear with me while I find the proper buttons to deal with this. Okay, if you are an attendee and you can hear this and you have a question, you can click the digital hand raising. I will see it and I will give you the mic to ask a question. Jeez, I see one hand being raised. Okay, Peter, I'm going to hand you the mic. Hi, Peter.
Yes, good morning. How are you this morning?
Good.
Just a question. I've got a 300 amp hour HP in a boat. Can I parallel a second one up with that without any harm?
Great question. No, unfortunately, right now, those batteries cannot be connected in series or parallel.
Okay. Is there any likelihood in the future that I'll be able to?
Yes, we're working on that as well.
Okay. And that would be possible with my existing battery?
I'm not sure about that yet. I probably not, but the product's in design right now. Ideally, we want to be able to retrofit it with prior technology, but from what I've seen in the design, it probably isn't. That battery you have now cannot be connected in parallel. I don't think we see a way of changing that.
No. Okay. Thank you for that.
You're welcome. Thank you. Okay, Toby, I see you still have your hand raised. How are you, Toby?
Hi, yeah, I'm fine, thank you. If I supply your batteries to a yacht owner and one of them fails and he's gone abroad, can I fly him out a replacement? Or how do I ship a replacement part to somebody who's gone to the Caribbean, for instance?
Good question. Flying a battery can be very challenging, a lithium battery. If the battery's below, man, I'm drawing a blank on the restriction.
Yeah, we're looking at RB100s, and they're above the FCA maximum, which I think is 100 watts. So that's pretty much everything.
Okay,
it's 100 or 150 watts.
Yeah, the regulations are in flux. I know but there's one that we've been abiding by. We've been able to ship RB100s. It's a 35 kilogram weight limit for sending a lithium battery as a package. What am I trying to say? When you're flying in an airplane, as carry-on, you can't take anything over 100 watts or watt hours. Excuse me.
Yeah.
When you're shipping as a cargo, that's the word I'm looking for. It's 35 kilograms. Now, the gotcha is some countries won't let you get through customs. So it gets sticky. So you got to put it on a boat.
I'm telling my customers this so that if they have a problem, they know that it's going to be a pain to resolve, basically. But I'm not anticipating the batteries breaking.
Good.
Okay, fantastic. Thank you.
Oh,
I'm putting 5 batteries in parallel, RB100 HPs. That'll be all right?
Yeah, yes. You might email us, just give us the specs if you could, just on the equipment so we have it logged.
Yes, okay, I will. There's sheet winches, electric winches and motors, hence why quite a few to keep the average current on each battery down a little bit.
Oh, I'd like to see that. I'd like to see that to make sure the current's down. Please do that.
Yeah, okay. Give me a couple of days.
Okay, great. Thank you.
Thank you. Bye-bye.
Just to touch on what Toby's question right there. We allow people to connect up to 4 batteries in parallel, but when you start getting into larger systems, we want to make sure that you don't damage the batteries or equipment. So anybody out there is considering making a large parallel bank, to please contact our tech support, our applications department, and we'll help review the design and make sure everything's proper. Okay. All right. Again, we're in the live Q&A section. Feel free to raise your digital hand. We've had a couple of good questions so far. Looks like Mac, you still have your hand up, so I'm going to unmute you. Hi, Mac. You still there? Oops. There we go, Mac. Now I have you online.
Okay, great. Can you hear me?
Yes.
Terrific. I sent an email in asking if it was all right to charge lithium batteries in a system where they would be the house bank and the start batteries would be AGM. The answer was yes, that's possible. It works just fine. And the reason is that the AGM charging profile works for lithium batteries. Could you elaborate on that?
Yes. there's a couple questions in there. First one, easier one, is the AGM charge profile. Why is that compatible for lithium batteries? For a 12-volt system, AGM batteries typically want to be charged from somewhere between 14.4 to 14.7 volts. Okay. That's very close to the same charge range that lithium batteries have, which we have 14.2 to 14.6. So if you're charging to an AGM charge profile, it's both batteries at the same time, they're going to get to their happy spot of in the mid 14 volts, be 100% charged. Your charger will do some extra acrobatics at the end on a finish or a float charge to make sure the AGM's happy, and where the lithium might already be charged. But again, the lithium can be overcharged or undercharged, and it's still there's not going to be detrimental effects. Now, I do want to ask you a question, because this is something we get often, is people want to connect AGMs in parallel with lithiums. If we gave you an AOK, might want to slap us on the back of the hand a little bit. We have people doing it, and it works. However, I don't know long term what's going to happen to that AGM battery. Their resting voltages are a little different, meaning if you charge them both up, take the charger off, that lithium's going to settle at 13.2. The AGM wants to settle about 12.9. Very similar, but there's typically going to be some current push from the lithium into that AGM battery to keep it to bring it up to the 13.2. So will it work, and is there danger? Yes, it'll work short term. People have done it. Is there some danger or damage that might be done to the AGM, or it might? I think it would shorten the life of the AGM at best, but I can't answer that degree. There just aren't a lot. There's a lot of testing it's occurred. So I'm going to throw a question back to you. Is there an isolator or something between the batteries, or do you truly have AGMs in parallel with lithium?
Good question. They're both tied into a Balmar regulator. So I'm talking when I'm at anchor, not on shore power. So I'm using a Balmar regulator on one of our two engines, and I'm not sure I have a correct answer for your question. It's going through that regulator. It gives priority to the start battery, and then it shifts over to the house bank, which right now is 4 big North Star 220 amp AGMs. Mm-hmm. So I'm not sure it does them in anything but a sequence. Mm-hmm. I'm not positive of that.
Got it. This is one of those system specific questions that I just want to say that, let's take a look. Anybody out there who's got a tough question like this, or a system specific question, there's two things we'd like to see. And one is a wiring diagram. And I know that's always kind of a high hurdle to get over, but if you can get something like that, get it to us, we can really evaluate it and see, if there's any concerns.
Okay, great.
So let's follow up. We'll take that question offline, contact us, and we'll evaluate it. But good question.
All right, thank you.
Sure. Okay. Peter or Toby. Can't remember who had the question about hooking 8 HPs in parallel. I didn't think I heard that, but whoever that was, go ahead and raise your hand again. I want to call on you. But Peter, looks like Peter has another question for right now. Hi, Peter. Peter, oh, sorry. Hi, Peter. You're able to talk.
Yes, no, I haven't got anything more to ask at this stage. Thank you.
Okay. And you were the gentleman asking about connecting RB300 HPs in parallel, right?
That's correct.
Okay. How many were you looking to parallel? Just 2 or more?
Only just 2, yes.
Okay. Yeah. Okay. Well, the answer didn't change.
Okay.
Right.
Well, I'm very happy. I've had my single 300 HP in service now for just over a month, and very happy with its performance. But I just would have liked more available current. Yeah. Sorry, more available capacity.
Yeah. Yeah, we get that request. So it's one of the limitations. We're trying to unlock Pandora, or, find the Rosetta Stone so we can all benefit from that.
Yeah, the only way I can see of doing it is to do it with some sort of changeover switch where you run basically two batteries, but it changes, through either a manual electronic switch.
Right. Okay. Well, hey, thanks for your contribution today, Peter.
Thank you.
Okay, so it's wide open right now. I sound like a radio talk show host, but we've got another 7 minutes or so. If anybody's got some questions, go ahead and feel free to get involved. I'm going to go back to our miscellaneous questions till I see some live ones come in. So we discussed the disposal process of a lithium iron phosphate. Here's one I kind of answered just a second ago in the live questions. Gentleman here has a marine application with 2 AD house batteries, 240 startings, a Cummins motor, 160 amp alternator, a generator, shore power, solar, almost every type of charge source fathomable. And he's asking, will it compatible? Will there be any issues? So this is ideal for really getting a wiring diagram from them or a system layout at best. And then talking about even a load analysis, what else is going to consume some of this charge current, what time of day are some of these things being fired up and contributing to the charge. If they're all going at once, it's a lot of batteries. Are the batteries isolated or not? So we want to kind of look at those things. Can't really answer it from on the surface right now. But there's a lot of users out there with more complex systems like this. And then you're going to lithium, it's want to make sure we don't there's an understand for concern. Let's make sure the system's compatible with the lithium and what issues there might be if it's not, and can they be resolved. So along those same lines, more simple worded question is there a table or set of questions or questionnaire they could fill out before they approach us with an issue? Or quite often this question probably originated from someone trying to size a battery or convert a lead acid battery. So again, the two things we'd love to see is, 3 things. What's the application? Do you have a wiring diagram and a load analysis? What are you going to be powering? For how long? And what's the power rating of that equipment? Okay. Oh, wow. I'm being corrected, Peter. Are you still there?
Yeah.
Yeah. So I apologize. Things move so fast here. Sometimes I get my specs mixed up, but I'm being corrected by Christine, who's the one answering the Q&A in the chats, that HP batteries can be hooked in parallel. However, we have concerns about the peak current that should not be doubled. So you can certainly add RB300 HPs, another one to your system and connect it in parallel. You'll have increased continuous current. We wouldn't want you to double that, but I think that battery's rated at 100 amps continuous current, which translates to about 1,200 watts, 1,300 watts. Hooking a second HP in line with that, you wouldn't want to double your continuous to 200 amps or 2,600 watts, but you could 75% increase it. So that gives you roughly 2,000 watts or 150 amps. But the peak, that reason people buy the HP so they can go to 800 amps for 3 seconds, you don't want to double that. You want to keep that at a single battery rating.
Yeah, well, I'm using mine at the moment for starting a Cummins QSB 5.9.
Is it? How's it doing?
It's doing well. I think that needed a cranking capacity of about 1,100 amps. So it seems to be doing that quite well.
Okay.
but I'm after the overnight cycling capacity, and that's why I'm looking for the second battery in that system.
Oh, super. So then you can do that. You can add a second battery to increase your slow draw capacity or your continuous current.
Okay.
And your capacity, you won't harm either battery.
So I should talk to our local agent here in Brisbane in Australia and say that I've been talking with you, and that's okay to do that then, eh?
Yes. Yes.
Okay. Thank you.
Okay,
very, very good. Pleased to hear that.
Yeah, I'm glad I caught that, or I was corrected. Have a good one.
Okay. Thank you to your assistant.
Yeah. Okay. Whew. Glad I got corrected. Hate to be wrong, but hey.
We all learn.
Okay. Resuming. Let's see here, we're on time. We got a minute to go. Let's see if there's any other questions. We might be able to round this out. This is the last one. I own a Lance camper with solar and wonder if a special charger is required. Well, we touched on that. More than likely, the charger is going to be compatible. Best thing to do is look at the manual, see if you have either an AGM setting, or you can change the program the voltages manually. A lot of converters, charge controllers, and inverters give you that capability. So, and if you don't have a manual, it's going to require a call to the manufacturer of the RV or the camper or the inverter or whatever charge device you happen to have. All right, that rounds out our webinar right on 59 minutes. So I want to thank everybody for attending this webinar and the last one. There'll be more to come. Stay tuned. We'll send out notices, and there's going to be two things. There's going to be a recording of the seminar available afterwards. We'll email you a link. And there'll also probably be a survey, again, that you can take, either if it's going to be connected right after you log off or emailed to you. If you could please do that. We really are, if you can't tell by now, we really are monitoring and taking the input from our customer base. So again, thank you for your attendance, and we appreciate it. And you guys have a great rest of the week. Bye-bye.